In this conversation, we talk with Tijs, an aspiring space enthusiast and team manager and co-founder of Aster.
Aster is a student team which is developing the first Eindhoven University CubeSat and is trying to make space accessible for students in the university.
And in the Brainport region.
Hi, Tijs. Nice to have you on this podcast. And yeah, we'll start just with a short introduction. Tell us about yourself, and tell me what you do.
All right, of course. Good afternoon. Thanks for having me first. My name is Tijs. I'm now a last year applied physics student. I hope to graduate next year. 2 years ago, I decided to do something more besides my studies, and that's when I started looking into some extracurricular activities, and I found out about student teams, and it really intrigued me, so I decided to join one. I'm basically from early days already pretty much a space enthusiast, so when I found Aster, I decided to join them. That's 2 years ago now. I started as a technical member there, but back in the day we didn't have too much roles defined. And gradually I worked myself up, and right now I'm in the position of team manager of Aster, and I'll continue to do so till the end of this academic year.
Okay.
Nice.
What does exactly Aster do? Because we tried searching on LinkedIn,
Yeah.
we looked into the website, and there are some things that I would say, like, if you go to the website and if you go to the mission, it says something different, I think, from LinkedIn.
Yeah, on the mission it's about the FENIX, it says, and on the LinkedIn it talks about like CubeSat to space.
Yeah, exactly. And I mean, I get the confusion. If you have to piece it all together from all the social media platforms we have, we're right now working into making one general thing. But it's a very logical thing, the FENIX mission. But let me explain first what the team is about. So we are the first space student team from the university. Our mission, our vision is to promote space engineering and education here in the Brainport region of Eindhoven. So not only the TUE, but also FONTIs or other institutions. And we do that by working and collaborating on space-related projects together with companies and organizations from the region. And the main reason that the team is founded is to build a cube satellite. And maybe I should explain a bit more what a cube satellite is.
Yeah,
Sure.
would be.
Yeah, so a cube satellite, that's a small spacecraft around the size of a Rubik's Cube. It's really small, but that makes it also affordable. And especially for poor students who don't have a lot of money, that's something nice. And it's also very standardized. There's a lot of knowledge out there already on how to build those things, which makes it also easier to start with it, because here in Eindhoven there has been no aerospace faculty or whatsoever. So that's the main reason we founded the team, to build this CubeSat. Later I will tell you more about what we want the CubeSat to do, but we found out it's pretty difficult to build from scratch a spacecraft, and I think you can imagine why that is. So we decided, because it also takes a while to develop it, the current plan is to develop it in 3 to 4 years, and people in a student team, they don't stay that long. They come, and when they graduate they leave the team, of course. So we also wanted to give something to those students before the CubeSat, some results, some deliverable to motivate them, and something to keep working with, because the CubeSat is in the beginning a lot of documentation and research. So we decided to do a startup mission basically as a stepping stone towards that satellite mission, and that's the FENIX project, which you read about.
Okay.
That's something we did last year.
Oh, it's already been done, right?
Yeah, kind of. So we developed a small integrated computer which can measure radiation in a few novel ways. And basically it was more easy, less requirement specific, and we finished it last year. The hardware side of things, it's now waiting basically in a closet to go for a launch. The launch has been delayed because the rocket launcher had some issues with the engine, but we did all we can. We finished it, we gave our team something to work on, and we're now waiting for the launch. And in the meantime we focus on the other projects that we currently have.
Okay.
Yeah, what rocket are you launching it on?
Yeah, so I think a year and a half ago we partnered up with a company here from Eindhoven called Spaceborne United.
Yeah.
They're more like a biological oriented company who want to investigate IVF clinics in space and want to see how the human reproduction system works there. And they're trying to schedule a flight as well with one of the payloads, and they mentioned they had some space left for us. So we got with a deal with them, and together we'll now go on a rocket flight. Initially it was scheduled to launch from Canada. Then after some delays we should have launched from Iceland. And the rocket launcher world is pretty uncertain. and now it's scheduled to go from the United Kingdom. And there's still a lot of uncertainty there, so I can't tell you too much about it. But we've done everything from our side we can. We're now waiting for it to happen, and then we can make also a big PR stunt about it, so that we can show the world that we could deliver something that can go to space, and it also makes it more easy to get partners and other people helping us out with the bigger CubeSat mission.
Yeah, that sounds super interesting, to be honest. Yeah, but the question arises is, how do you determine the goal of what to do? For example, you came up with the FENIX, and now you're doing like cubic satellite. Who comes up with those ideas? Like, and what is the purpose of, for example, this like cube satellite that you're building now?
Yeah, okay, so it should fit in the bigger vision we have to promote space engineering and education in the region. And for the cube satellite, what we wanted to do is, because you can use your satellite for three purposes. Either you look out into the universe with it, but the cube satellite is very small and the optical elements inside the satellite need to be big in order to receive a lot of light. So that's not so what's suited for a CubeSat. The second thing is you look down to Earth, but then you have the same issue with the instruments. And the third thing is you use the space environment to conduct testing or experiments. And that's exactly what we want the CubeSat to do. We want to create a platform with which some of the key technologies that Eindhoven is already rich of, so think about semiconductors, photonics, artificial intelligence, wireless systems, we want to bring them to space and see if they can be further developed. And you have to imagine space, a lot of people ask, why do you go to space? You can do everything almost you want on Earth. But the space environment in the past has proven to be an excellent kind of cradle for many technologies. Think about touchscreens, solar panels, lasers. And we want to make advantage of the weightlessness of radiation there, the vacuum, to see if those technologies can be further developed and if we can find more applications for them.
Okay, you mentioned, quick question, you mentioned touchscreens. How it is associated with space? Like how does space exploration help?
Yeah, so basically it was invented for astronauts because of the thick suits that you can just touch the screen instead of all the other things. It's some invention there. Yeah, it's a fun fact. So that's what we want the CubeSat to do. We want to incorporate it with some payloads from Eindhoven and the Netherlands, and to see how they respond in space, what the applications are, what are the limitations, advantages. That's basically the mission of the satellite itself. And with that, we also try to make people more enthusiastic about space and see the need for it.
Yeah. Space is notorious for being like, it's very expensive to put something in space, right? How do you do that? How do you get the funds to put something in space?
Yeah, that's a good question, because in the beginning, when you don't have anything, who will give you money because they believe in you? Because you don't have something to show for it. And space is very difficult. So yeah, you need to sell a good story in order to get funding from outside partners. So the main sponsor we had in the beginning was the university itself. So I'm not sure if you're familiar with Innovation Space.
Mm-hmm.
Yeah, so they're basically the kind of umbrella above all the student teams. That's also where we are located. It's in the Matrix building on this campus. And there we have our own office space, and we also get the main monetary funding from them. But the rest we have to outsource. And for space, it's pretty difficult. You have to imagine, because Eindhoven doesn't have really a space industry, also not in companies. And many companies don't have space in their business model originally. So that's something you really need to align with them. So monetary sponsoring, that's not something we look for in companies. We're more into the components or parts we get from companies. So for example, a 3D metal printing company, we have recently partnered up with them, also from Eindhoven, and they're trying to look if their materials are suitable for space. And if so, it might open a new market for them. So that's what you try to do. You don't necessarily want cash, but you try to get testing facilities, components to build that spacecraft, and also expertise. And that's something that's a bit lacking here, I have to say. Like, we have all the disciplines you need for building a spacecraft. So think about mechanical engineering, electrical, computer science, everything, but not the space systems engineering above it. So we're also looking for companies who have built spacecrafts before. Think about European Space Agency, with whom we're partnered, or the Dutch Aerospace Institute, NLR. Those are also our partners in order to give us the advice and expertise we need to embark on this journey.
Yeah, can you tell us about what is the mission profile for the satellite? Like, what orbit will it reach, or like how long will it stay in space?
Right now we have indeed finished our mission statement of the Cube satellite. We're now working into the broader system architecture, so a bit high level still.
Yeah.
But that's all necessary because we want to adapt the space standards that are used. So the ESA, NASA, they all use some kind of standards. Think about definitions, think about documentation standards. And in order to get help from those professionals and experts, we also want to adapt the style that they're using. And that's currently where we are. And indeed, to go back to your question about the mission which we have, as I mentioned, we want to use this platform to develop technologies, but which technologies are that? And currently, we have partnered up with a photonics company. Do you know what photonics is, or should I?
You can maybe briefly
yeah.
explain.
So yeah, okay. Basically, we want to bring photonics to space. With photonics, I think the best way to explain it is to make a kind of example with your phone. Your phone, it works on electronics. You have to charge it, and electronic circuits with electrons, they run through it. It has a lot of advantages, but there's a lot of resistance. A lot of heat is generated, and with photonics, we don't use electrons or electricity, but we use light as means of propagation of information. So that's something that's really big and growing here on the TUE. That's the photonics kind of industry, and even the big players like ASML, they're looking into that as well, to process with light, with photons instead of electrons. And we have found a company called Photon First, who are specialized in photonic sensors. So basically you have to think about fiber optics through which your internet runs. You send light through it, and what they do is they can use them as sensors to detect temperature, pressure, or strain with those fibers. They bring gratings in the fibers, and by bending or subjecting the fibers to different conditions, the wavelength you send through the fibers changes, and with that you can say something about the conditions that are happening. And for example, in space. And those photonics is something we want to incorporate in the satellite because it's never been done in space before. And we want to see how that works and if there is a field for it in the space industry, because photonics has a lot of advantages. For example, it responds different to radiation. Light responds different to radiation and electrons. So if you have a solar storm, for example, in space, then your regular electronic chip gets fried. But photonics, that's different response. And we want to find out what's the limits of those technologies. It's light, it's very small, so you can use your spacecraft for more things. And if we can show that a small cube satellite can do this, then it can be applied to many more spacecrafts. So that's the main mission we currently have, and we're working out.
Okay.
Nice.
And yeah, maybe photonics. Is photonics associated with laser communication as well? And yeah, you were talking about faster communication and different communication from electronics part. And yeah, I just want to ask, because I was in this one fair, and I was talking with a engineer from VDL, I think so, and they were making laser communication via satellites.
Yeah, so that's mainly, I think, involved with outside satellite communication. And with photonics, it's more internally.
Okay.
So with laser, like LiDAR, for example, laser communication, that's something they recently did with the International Space Station as well. They use laser communication to go back to the ground. It's a lot of advantages, but you need big spacecrafts to start with it, because the laser needs a lot of power. And a CubeSat, which is like this size, you can't do that. So no, that's a bit out of the scope of our first mission, but of course we don't want to keep it with one CubeSat. After we finish it, I think there will be even more enthusiasts wanting to work on a second one. But right now we're just focusing on the internal communication, with photonics, and we have just a regular comm system to communicate back to the ground.
Okay, makes sense. And yeah, one more question about laser communication. I'm not sure how you're familiar with this, but yeah, I don't have any experience, so it's quite interesting. Is it possible to do laser communication in the like across ground stations, or like?
Yeah, so the thing is with laser communication, well, they say it's laser communication, but still it's operating often in the infrared spectrum, so you can't see it, even though it's called laser communication. But the main thing is the atmosphere is interfering with it a lot. So you really need to be really on top of where you are communicating with. So between ground stations on the ground, it doesn't work. If you have a wall in between or cloud, then there's not much you can do about it. But between satellites, laser communication is being tested. Yeah.
Okay. Okay.
Okay. So another question about the satellite. How will you, like, actually overall, how do satellites prevent collisions? And will you do something for that?
Yeah, so that's a big issue. And that's space debris. And that's something that we've been realizing in the past. decades, humanity has been realizing it that we're throwing all kinds of things into orbit, but most of them don't come back, and they stay there forever. And by sending more up there, you increase the chances of collision, which creates even smaller particles, which increases the chances of collision even more. So in the end, you have some kind of effect with which you just contaminate your entire orbit. And that's something that all space missions, I think, from a few years away, will need to incorporate in their mission plan. So a space mission consists out of a few phases. First, you have the launch, of course, in the rocket. Then you have the commissioning phase, where you turn everything on, your solar panels. If you have any mechanical things, you need to unfold them. Your antenna, for example, you need to turn on all your instruments, make sure you establish the proper connection. And then you go into the operations phase. But afterwards, what many people forget is that there's also a decommissioning phase. You need to make sure your spacecraft is not a hazard for other spacecrafts, for human spaceflight, that's very important. But also not that for a CubeSat it's very small, but bigger spacecrafts can also crash back on Earth, and that can cause some hazard as well. So that's something you need to take into account. And fortunately, a small spacecraft as a CubeSat, it can burn up in the atmosphere very easily. We don't want to send it to a too higher orbit, so the lower the orbit, the faster it falls back. So we want to send it to low Earth orbit. That means around the altitude of the International Space Station or the Hubble telescope. It's around 500 kilometers. It can stay there for like a couple of years. If you have some propulsion, which is possible in CubeSats now as well, you can extend that even more. And afterwards, you turn everything off, you drain your batteries, and it will burn up into the atmosphere. And that's also something you should incorporate in your mission plan.
Okay.
Yeah, actually, I don't know if this is quite related to this, but for example, with SpaceX launching like hundreds of Starlink satellites, do you know maybe if they plan to somehow like deorbit them, or will they just be used up after?
Yeah, so the thing with the bigger companies in the past or the space agencies, it takes energy and time to decommission your spacecraft. And with that same energy and time, you could use it for gathering more data and getting more money, so to say. You could use your spacecraft longer, and it creates more value. So they didn't bother about what would happen afterwards. We want just to extend the lifetime of our spacecraft. I'm not sure how they've planned it currently with SpaceX or the biggest space agencies, but I think there is some kind of understanding and agreement among all players in the world to make sure we don't mess it up even more. There are missions being developed by ESA and NASA as well to clean up even orbits. And there are a lot of things they're talking about, a lot of interest, and that's a good thing that there's a lot of people realize what they're doing, and I think that's a good thing.
Okay. So let's maybe turn the topic to the student team in general. About the social things more. So like, what are the benefits of being a team leader, and what do you like the most of being
so
a team
really
leader?
about my position?
Yes, indeed.
Ooh,
Not
good
about
question.
the space, but
So I think most people who want to join our student team, when they are space enthusiasts, they say, oh cool, I want to work on the technical side, I want to be an engineer. And I agree with them. Working with space hardware as an engineer, that's probably one of the best things you can do, really on the technological frontier of what's possible, and that's something you work on. It's really challenging, and it pays off in the end. That's great. But for me personally, I want to develop on different areas as well, and I think that's what a student team is very good for. So not only on the technical side, I've done it, and of course I need to have an understanding of what we're working on, but developing myself in different areas such as management, human resources, external affairs, public relations, or even finance, that's also something really valuable which you can use later on in your life in any company you work at. It's something they don't teach you at the university itself per se, and a student team is the perfect opportunity to develop that further and to see if you like it, to do more.
Makes sense. Totally makes sense. I can totally in the way to relate to that. Doing such things.
Yeah, that's we're doing this podcast also.
It takes a lot of energy, and
Of course, it takes a lot of responsibility to be a team manager, but that's something that's also great to do. You grow your network as well.
Yeah.
You go outside to all kinds of space events with the big players in the space industry.
Indeed.
I often go to ESA. It's a long train ride from Eindhoven. But it's really worth it because, of course, the knowledge is not there, so I really have to bring it to Eindhoven. Quite literally, I have to go there to bring it back. I have to create name, I have to do pitching, presentations, and it teaches you a lot of different things, which are great to do. So if any student ever wants to do something besides their studies, please consider a student team. It pays off really well in your resume as well, but also just in personal development.
Yeah. Especially in space exploration, where like you can't normally do that, and I believe it's super interesting. This topic. As
Yeah.
well. Yeah.
Like it seems like you're in your bachelor's, right? And for me, the most fascinating thing was like space seems such a faraway thing, like quite unattainable for, let's say, like a regular student. But the fact that you're doing like a student team that is sending something to space, I think this is the coolest thing. Like how
Yeah, but
you
it
can.
doesn't mean it's easy, right? I mean,
No.
that's a
It's
challenge. We're doing this in a place where it has never been done before.
yeah.
And
yeah.
even if we have an aerospace faculty, a full booming space industry like Delft, for example, has, still it would be very difficult to set something
Yeah,
up
yeah.
from the start. So we have all those things, but that makes it even better because
Yeah.
we like the challenge to do it. And of course, there are setbacks, there are problems we're facing and issues, but we always overcome them. We always try our best, and we've motivated people. And I think that drives them as well. Is you don't get paid for it, you don't get credits. So everyone in the team, they are really motivated, because otherwise they wouldn't be there. And that keeps each other together, and that pulls us through. You know, everyone who pulls the cart, and that's something I really like about my team.
Yeah,
Nice.
that's so cool. Yeah. You mentioned Delft. Do you have any competition as a student teams? And also, Delft I think has aerospace engineering.
Yeah.
Do you know something about TV, like making this as a bachelor's program? Or
I wouldn't say there is much competition here.
Okay.
They are originally historically seen more into the space field. We believe we could also benefit from it as Eindhoven. Like I mentioned, with all our technologies, I think space is a perfect opportunity for them to be further developed, to open up new markets. We are in contact with some of the Delft student teams. They even have also like a kind of starting up CubeSat team. So we're also in contact with them with some Delft professors, some of our supervisors of our student team that work at Delft as well. Which is great. I mean, we have to use it for the best, but also other student teams. There is kind of a collaboration going on between all technical universities in the Netherlands. It's called 4TU, 4 Technical Universities, and we also have regular activities together. Where all the student teams from Delft, from Eindhoven, from Twente, and from Wageningen, they just get together and we share knowledge and how we do things. And in February, we even have a trip planned to Delft to go to the student teams there. And I think especially for Aster, to go to a place where there are multiple space student teams, that's great for us. To see how they do it, what challenges they face, and that's great.
But do you bring your own team to such networking events, or?
Yeah, so it's basically who can go and wants to go can go, but
Okay.
a lot of people already have some connections personally in Delft, like a lot of friends there, or so I think we go there with 8 people probably, something like that, which is great.
How many people do you have in the team, and maybe in the board? I don't know if there's a difference in your association, like student team, not association.
Yeah, so we started pretty small when I joined the team. Like I mentioned earlier, we didn't have a specific position or role or function. We were with like 8 people, but we were starting up, and that's around a year and a half, 2 years ago now. And we gradually grew in terms of size. Of course, when we have a recruitment event, we're the only one with the space banner, right? So everyone who likes space, they just go to us. A lot of car teams, a lot of automotive teams, sustainability teams. That's great, but we don't have that much competition here. That's unique. Right now, we are with 28 students in the team, we're growing. We now have management of 4 people in the board, but we do want a bigger board. But it's pretty difficult. Like I mentioned, people who join the team often want to do technical stuff, and I can't blame them. I mean, it's very nice to work on a spacecraft, but a team needs more people to function properly than just technical members.
That's true. But yeah, I feel like being a team leader as you are takes a lot of time. How does it impact like your studies? And you still said that you're planning to finish this year. How do you manage it? Like it should be quite difficult.
I think that's really personal. I do 2 courses next to my stay in the team, but I also just have a job in Eindhoven. So I do a lot of things next to my studies. I can manage right now with 2 courses and then student team position. On paper, I spend as much time as all the other members in the team, but in reality, between the lines, I usually do quite some more. but I like to do it. It's necessary, and it keeps the team going, and I think that's important.
Okay.
Yeah, so will you finish? Wait, when did you start your studies?
So I'm now a third year student.
Okay, and you finish in the fourth year.
Yeah, in the fourth year. So my graduation project starts in September, probably around that time.
What are the perspectives for after you graduate? Will you still be involved with Aster, and what are the possibilities?
Yeah,
there?
so we have a big alumni club of people. So people who leave the team, of course, they're still invited to some of the bonding events we have, some of the parties we have. They stay in touch with the team, and they're also, most of them are available for questions or anything. So also when I would leave, and I would encourage all the other members when they leave as well, to stay active as kind of an advisory person, to give them any questions or anything, the know-how, because knowledge transfer is really important. When that's also maybe important to mention. Most student teams, they have a yearly cycle. Every year a new team goes in. With us, that's not the case. You can stay as long as you want, and that means there's also overlap with people leaving and people staying. So that means knowledge gets retained better in the team, and that's really important for the space team, because you really need that knowledge to be kept in the team.
Isn't it like quite sad to after like having spent a lot of time and worked on this project that you care about, just to finish your studies and then you can't do it anymore? Because like if it's a student team and you're not a student, right, you can't
no,
be
so
a contributor.
you can be a member if you're not studying here in
yeah.
Eindhoven, which also makes it difficult. But I think it's good to, when you have stayed here for quite some time, to give the reins to someone else to make them develop it further in the way they see fit. I think that gives a lot of more freedom to people, and I think that's the nature of a student team in the end. People come, people go. So.
Okay, makes sense. Do you?
Oh yeah. So now I guess a bit about you. How did you become interested in space? And
well, I won't say there was one moment in time when I said, "Oh, like now I'm interested in space." I always liked like the most impossible things, and space engineering, of course, is one of the most advanced branches of engineering. The space environment is something we couldn't have imagined. It's only been there for the past 60 years, and we've been to the moon, you say, and there are a lot of things to look forward to. So the new moon landings that are upcoming, but also maybe missions to Mars and all those kind of unknown things. Working on the frontier and you don't know what you're doing, I think that's great, and that really drives me. And I also want to continue my career in the space industry. So you mentioned, you asked me earlier what I want to do after I graduate, and I'm thinking about doing my master's in aerospace engineering in Delft. Maybe you would have guessed, but yeah.
What would be your dream company after finishing masters? And like, do you want to work as a technician in a space field, or more as a manager?
I think I would rather do more into the management side of things. Maybe ESA, but I'm not sure about that. It's far away still. But yeah, I think that management position is a bit more suited for me. That's something I learned in Aster itself. So I started as a technical member, but over time some vacancies became available in the management positions, and I first wasn't sure, but in the end I felt like it was the right decision for me, and I'm really happy I did that. So.
Yeah. Okay. Nice to hear. Yeah. Do you have any?
So this next year is probably going to be like big for space. There's a lot of new rockets and missions.
Mm-hmm.
Do you follow actually like space news? And like, what is the most exciting thing for you about space exploration right now?
Yes, that's something we also want to do in the team. We're not just a team of engineers, we're also a team of space enthusiasts. And we really want to grow that space community. Yeah. Not just a student team working on things and going home afterwards. We really want to share our enthusiasm for space as well. So we also we share space news with each other. We regularly talk about it. And for me, of course, the Artemis missions are a big thing that are happening. Unfortunately, a few weeks ago, they have postponed it an entire year. Yeah. Maybe you've seen it. But that's the nature of space engineering as well. Things get delayed. Like I mentioned, our first mission, the launch is delayed. That's just the way it is. You have to cope with it and try your best.
Actually, do you do like events for people who want to talk about space exploration and like space enthusiasts?
Yeah, so last year we organized with the team an event. Was in auditorium in the Senaatzaal where we invited a speaker from ESA and our two partners, our Photonics partner and the partner Spaceborne United. We gave it to all students who want to be there. You could also get my future points for it to make it even more interesting. There was free lunch. That's something we did last year. We were thinking of doing a similar event this year as well, but we were a bit unsure when to plan it. But yeah, we also want to host events internally for the team, so we always have recurring bonding events. And if people really want to talk about space, we have on our website, asterinspace.org, we have a link to a coffee chat forum. Just fill it in. Usually people fill it in if they want to join the team, but you can also fill it in if you just want to talk about space. That's also fine. Then we plan a moment with you where we just schedule a chat during lunch. We have some coffee, we have stroopwafels as well to make it even better for people. And we talk about space, and if you're interested in joining the team, then you can become a trial member and get into the process.
Okay, and so let's say you join as a trial member. What's next? How can you become a
Yeah,
full
so
member?
our team is structured in the sense that we have every Monday evening a team evening. The entire team gets together. First we have a meeting. We share updates of the past week, what everyone did, but general, not really in depth. And then we have a work session, or sometimes we even invite a company to give a presentation about what they're doing. Sometimes we let one of our members present about what they worked on. And then we have a work session in the rest of the evening where everyone sits together basically doing their own thing, can ask questions, and you get to know the people in the team, but you also can get help from people around you. If you just have a question, you just say it and someone can help you out with that. And we invite the trial members then for those Monday evenings, and they get to know the team in the beginning. They just have a look around, and space engineering is pretty complex, so you can't immediately start doing stuff. You have to know what you're doing. So you just have a look around, see what kind of branch you like in the team, and then gradually you define your own tasks and role, and we talk about it more, and then you are basically part of the team. It's a bit of an informal process, I should say. And that's something that our technical team is now structured in. So most people who join for tech, they either go to software, to the mechanical side of the team, to communications, or to the EPS, electrical power systems. So that's what our team is structured in. And just have a look around, see what fits you. And even, for example, if you study computer science, but you want to work on the mechanical side of the CubeSat, that's completely possible. We encourage people to do whatever they want to do and to personally grow in those directions as well. And that's something we really want to stimulate in a team, that you can grow in whatever field you like to do.
How much time do you have to spend as a member?
Yeah, so we say around 8 to 10 hours, and that includes all the team evening, of course. Throughout the week, there's also a technical meeting for the technical people, a PR meeting for the public relations team, and we also have sometimes a board meeting for the board. So including those meetings, 8 to 10 hours a week. But of course, during exams, we actually go on radio silence because people need to do their exams properly. If they can't study here, they can't stay in the team. So we want them to pass their courses as well. And then in the kind of first weeks of the quarter, they usually spend a bit more time. And we're not strict with anything, but as long as you get your tasks and responsibilities done, it's all right.
Okay.
Yeah.
Maybe I have one question. Your own opinion, change of the topic, but your opinion about space tourism. Do you think it's a waste of energy, or do people have to do it?
No, I think it's very good to do, and especially to create awareness of the planet itself.
Okay.
So I've spoken to some astronauts already. That's also a nice perk if you join a student team with space. You have some events where you see astronauts, and they're all very concerned about the world, about climate change. And a lot of people tell me, why go to space? We have problems on Earth. Why don't you invest time and money in solving the issues here? And then the best response I have is to say that, but going to space, it changes your perspective on Earth itself. Yeah. Looking back and seeing how fragile our world is, that's all the astronauts I spoke, 2 of them, they all mentioned that when they look back at Earth, they really saw Earth as a fragile place, a unique, rare thing, of which only one exists, as far as we know, in the entire universe, and we really have to look after it. So that's also what the astronauts do after they retire. For example, André Kuipers, the Dutch astronaut, is now very concerned with the world, with the environment, and setting up programs and campaigns to really create awareness there. I've talked to Pedro Duque, that's the Spanish astronaut. He is now the Minister of, I believe, of Education in Spain. And also more active in trying to create awareness with people. That's really important. And I think space tourism can help there as well. I would say send all the climate critics and all flat earthers into space. Let them experience the way it is, And then all the political leaders, let's send them to space and show them how fragile our world is, and that we only have one of it. And I think that would create a better understanding of the world itself and of that we should look after it more properly.
Yeah, actually, talking about this, there is a famous picture from Apollo 8, which is called Earthrise, which shows Earth over the moon, right?
Yeah.
And I think, for me personally, this is the best thing you need to drive the point of Earth preservation and climate change, and that we need to care for it. Just seeing that picture, seeing a small, or actually there's another Voyager picture also.
The pale blue dot.
Pale blue dot.
Exactly.
Yeah. And it's so powerful, seeing in the vastness of space, just a tiny blue dot.
Yeah, and that already creates some awareness. So imagine sending people up there,
yeah.
And especially those who have influence in the policies that are made in the world. I think it would help a lot into getting all the climate policies there. And like I mentioned, going to space also is good for technological developments. So there are a lot of advantages to it, and that's what we try to do as Aster to really create that in Eindhoven.
You mentioned that you talked with the astronauts. I think most of the technical guys that grew up in their childhood thought about being an astronaut. Did you?
Possibly, yeah.
Yeah, I'm not sure. I had that dream myself. I think so.
Had or have?
Had maybe. It's quite interesting now, but I'm not sure. There's a lot of things to consider. But I want to ask. Maybe you ask them what is the path? How do you become an astronaut? What do you have to do? Because there's so few in the world.
Yeah, but
how do they pick them? And
I think it has to do with determination a lot. There is no major in being an astronaut. There's no study to go to. You have to be, I think, educated in STEM. So. Technology, science, engineering, those things. Then that's what you need to become an astronaut, but also medicine. Like the Dutch astronaut André Kuipers, he studied geneeskunde, medicine, and I think you have to. Most of them were also part in the military before, like a pilot or anything. If you have if you have a pilot's license, that also helps a lot. But determination, I think, is the best to do. Find something for which you need to go to space. Because eventually most astronauts are researchers doing experiments in space. So if you fit in that picture and you try and you apply, because sometimes they have those vacancies for astronauts of the European Space Agency, you might have a chance. But the thing is, more astronauts are needed in the end. If you look at SpaceX Starship, for example, almost 100 people can fit in when it's operational. That means you can send 100 people at once to space. The chances are more likely you will get in then if more people need to go to space. So I think the need for astronauts will increase, and that's a good thing if you want to become an astronaut.
That's cool.
Do you think the third flight will be successful of Starship?
Of Starship? Yeah, so that's also something we do with the team. We watch those launches, so when the launch is happening, for example, Starship, someone posts like NASA TV or anything, or SpaceX TV, and then we have a look with the team about it. I don't know. I think, the second flight was more successful than the first one. If they keep this pattern, then it will be successful, But I don't know.
It's hard to tell. Do you have anything more? Do you have maybe questions for us? I don't know. In general?
Not per se, no.
Okay. Then I guess the last question. Have you played Kerbal Space Program?
Oh wow, yeah. We have some members. I didn't play it myself.
Okay.
I don't have much time for it. Maybe, I'm busy with my team management and stuff. But I know some people from the team who play it or watch videos. Other people doing it.
Okay.
What is that exactly?
It's a video game.
It's a video game which it's kind of a spacecraft simulator where you have to launch and you have to get into orbit and you have to build your spacecraft. And it's very realistic, or you mod it and it's not. But if you turn gravity off, for example.
Okay.
Yeah. So.
Yeah, I
Yeah.
guess.
Yeah, so if I can do one more announcement for people who
Yeah.
might want to join the student team. Currently, we always have open positions. We always want to grow. If you are interested to know more about Aster, you can find us on the TV website on the student teams page. You can find a link there to our website or go to asterinspace.org. Check it out. Fill in the contact form if you want to know more. We'll pick up contact with you. Currently, we are looking for two types of people, kind of. So either a management position, think about human resources, public relations, finance management, anything that I'm doing currently. And on the other side, we have some vacancies for technical people as well, but specifically for electrical engineers. You don't have to be an electrical engineer in order to apply, of course, if you want to know more about it. But we need some people who can do good PCB design, so printed circuit boards, creating electronic circuits. And we also need some people for electrical power systems, so from battery to solar panel to onboard computer, anything electrical driven that in the satellite, we need people to do that, enthusiasts for it.
Yeah.
If you're interested in that position, then please go to our website, astronaut.org.
And I think it's really unique opportunity. You can't like just I don't know do anything else except like if you're interested in space, join such student team. Yeah.
Yeah,
It really
and
sparked my personal
we're
interest,
also
to be
at
honest.
the recruitment event on Leap Day. I believe it's February 29. I'm not sure if that's Leap Day. Then there's a recruitment event of all the student teams. We're there as well with the banner and our stand with some flyers as well. So if you want to know more about us, then you can also go there to us and talk to one of our members.
Okay. Yeah.
Okay.
Yeah. Thank you for coming.
Yeah, thanks.
Thank you for sharing your experience.
Thank you very much.
It was called interesting conversation. I would say. Yeah.